So if we look at an example, now getting back specifically to EVs and lithium-ion battery systems, typically it starts with the OEM defining their product goals, product design, and then getting into sourcing, how we're actually going to source, which suppliers we're going to use. And then once they start the sourcing mode, then it gets to the supplier. And this example could be the lithium-ion battery system, various sub-suppliers within that space. They'll start with quoting. And before they're able to quote, need to think about how we're going to design this product, how we're going to manufacture the product, and also how are we going to reduce the cost overall. And then third, once it then a supplier is selected, then goes to the OEM and start thinking about how we're going to assemble. So if we look at an illustration on the product goals and the OEM side, profitability and cost targets are often developed and thought about first. So if you look at the illustration on the bottom here, we just put OEM cost target for illustrative purposes on the left. And then as it moves along, maybe it gets to the supplier and they come up with a target cost, maybe using a different tool, different method. We'll just put it here to the right for now. And then what happens is they go and quote it. Maybe it is pricing that's developed based on cost. Maybe there's other means of how they come up with their pricing. Put the supplier quote all the way on the right-hand side here. And when you look at this diagram, the OEM is going to have a certain willingness to source and perhaps not go above this line shown here. And the supplier is also going to have a willingness to quote. Maybe they don't want to go below this line. The ability to tighten that gap and the closer that is really will help result in success and be able to get through the process faster from an OEM and also supplier perspective. So how do companies gain confidence to tighten that gap? Either the OEM moving to the right or the supplier having willingness to move to the left. More often than not, there's several rounds. Suppliers might go through more than one round if they're lucky, maybe 2, 3 if they have really good, strong performance and design targets. But that can really add to the time of an OEM be able to launch on time. They might go through several rounds, but one way in order to reduce that is using digital manufacturing simulation to tighten this gap here and look for design to cost, design for manufacturability insights to reduce overall. And so with this, and we're going to show an example here in a battery system, suppliers and OEMs can move their cost targets to the left. So we're going to take a look next at 3 uses of digital manufacturing simulation for lithium-ion battery management systems. And so in the diagram at the beginning, we talked about the overall battery management system, and it's one key area within the overall battery system. And we're going to show 3 use cases. First, looking at how it can be used for fast and accurate product cost simulation. Second, on design and manufacturability insights. And then third, on automated cost and manufacturability insight. Before we do that, it helps to just set the scene and provide a little bit of background of what actually is in a battery management system and battery disconnect unit. So if you break down a battery management system, I'm going to call it here as BMS, over on the right-hand side here, you'd find that it contains software that's often embedded on a printed circuit board, but it also contains sensors to read out current, voltage, and temperature. And the main purpose of this is to really ensure that the battery is operating safely and optimally performing from a state of health and state of charge perspective. Although scaled up quite a bit in terms of voltage and current levels, it's somewhat similar to the ability of your phone to read out state of health and state of charge when you go into diagnostics. And then in some architectures, there's another product called the battery disconnect unit that can be combined with the battery management system, but this ensures safe power distribution and switching capability and providing high voltage and current disconnect functionality. If you look at these, sometimes the BMS or the software embedded on a PCB can be integrated directly into a battery disconnect unit, and sometimes vice versa. Some common components within the BMS or BDU, if you look at the bottom right, can include high voltage contactors, current sensors, different fusing products, could be thermally or maybe using a pyrotechnic device, connectors, PCBAs, wire harnesses, bus bars, and then some type of housing or enclosure, often with a certain IP rating. All right, so let's take a look at the three use cases, starting with providing fast and accurate product cost simulation. Here's an example using a housing. On the right-hand side here, a housing or enclosure for a battery disconnect unit. Digital manufacturing simulation software can instantly and precisely determine the cost from a CAD model. And so in this example, maybe a designer is thinking about switching from injection molding to another area, or from die casting to injection molding. And in different scenarios can easily see how much that switch might be able to save in terms of cost savings. And doing this with a cloud-based platform enables global teams a fast way to iterate. Use case number 2, still sticking with that same component, looking at the housing. Here looking at design for manufacturability insights. What this software can provide is overall design guidance, giving it a DFM risk, high, medium, low, and giving guidance issues, and the ability to look at a certain number and prioritize those. In this example, although showing a simpler example here of an enclosure with sharp corners, and how the software would be able to give insight to say, maybe think about putting a radius on those corners and rounding out the edges, providing insight and quick tips of how to do that as a manufacturer and someone in manufacturing actually going to make the product, and providing helpful links of how to actually give some insights and industry common practices. And then third, not only just looking at the housing, but now looking at the overall bill of material within the BMS or BDU, the ability to automate manufacturing insight. Looking at the right-hand side here, looking at the 5 steps, checking your CAD into your PLM. You can automate costing of these checked-in parts, and it can work behind the scenes. Design engineer can come back into the office, tomorrow and see that report of how it's prioritized, and now start to look at the key areas of concern. So in summary, looking at digital manufacturing simulation and the benefits of using it within a lithium-ion battery system,